Well, hello, everyone, and good morning. This is Rebecca Dallin with the City of Oklahoma City Stormwater Quality and COSWA. I'd like to officially welcome everyone to this special training event. If anyone would like to receive a certificate of attendance for today's session, please send me an email to request it. I'll put my email address into chat so you'll have it handy. We would like to ask for you guys to keep yourselves muted during this presentation. If you have any questions for our guest speaker, please do type those into chat. So our guest speaker today is Miss Mary Halley from WSP. Mary has nearly 30 years of experience working for local governments on stormwater management programs. Stormwater management program projects. Her expertise spans local governments in over a dozen states across 5 EPA regions. Within WSP, she is a subject matter expert in the areas of municipal stormwater management, MTDs, MS4 regulatory requirements, stormwater financing, post-construction stormwater management, green infrastructure, and master planning. Thank you so much, Mary, for being willing to share your information with us today. So please take it away.
Thank you. I appreciate being asked to do this. I'm happy to get back in front of folks from Oklahoma as I sit here in my office in Knoxville, Tennessee. Hopefully you can see my screen by now. Great.
Yes.
And as you can see, I get around, professionally speaking. So I've been working in a lot of local governments, pretty much east of the Rockies. As far west as I've gone is Boulder, Colorado. But I enjoy getting out and meeting folks. I enjoy learning what they're doing what everyone is doing for stormwater quality. And we're all alike in many ways, but we're all different in many ways. So this particular subject of manufactured treatment devices is something that just about every state in the United States is grappling with. They've got it on their plate to think about, and lo and behold, it's come to Oklahoma as well now. So go ahead and sit back. If you've got questions, go ahead and put them in the chat, and I'll try to remember to stop on occasion to ask if there are any questions, but we will have time at the end for questions. So I'm going to introduce you to manufactured treatment devices and talk about the different types of devices that are out there. A lot of folks are very familiar with hydrodynamic separation units, but manufacturers of these devices have done very well in keeping up with stormwater quality technology and flood control technology. And so there's a lot of different things out there now that maybe you aren't aware of. Talk a little bit about how these things are sized. They're sized differently from most other structural post-construction BMPs. There are some industry-wide standards out there that as a consultant to municipal governments who writes a lot of policy and ordinances, these standards are something that I think are important to the community at large, especially to our MS4 permittees. And then I'll talk about crafting local government policies. So number 5 and 6 there at the bottom of the screen are essentially the same thing. Is, what does this mean for the OKR permit as you bring it into your local government program, so your stormwater program? So let's start with an introduction. So manufactured treatment devices are proprietary devices usually, and they were formerly known as proprietary BMPs. Back in the late 1990s and the early 2000s are when we began to see proprietary BMPs. That is the name that they had at the time. But as the MS4 permits have evolved, as stormwater quality technology has evolved, and as we've moved away from acronyms like BMP, when we're talking about post-construction, a lot of states have begun using an acronym other than BMP for post-construction, because BMP in a lot of folks' minds means erosion control. And that's not what we're talking about here today. We're talking about post-construction structural practices. So manufacturers and stakeholders have gotten away from using proprietary BMPs, and we're now using manufactured treatment devices by and large. You'll still hear BMPs out there. Obviously, still in Oklahoma, BMP is a post-construction word as well as an erosion control word. But if you hear me say SCM, just know that I'm talking about post-construction BMPs. I work with a lot of communities that use the term SCM, and I might inadvertently change what I say. What I mean is a proprietary BMP, a post-construction practice. So MTDs are usually purchased from manufacturers and vendors, not all the time. If you think about oil water separators, a lot of times I've seen those manufactured on site, on the site that they're going to be placed, and they're manufactured by an engineer, not necessarily a manufacturer of that particular device. So they're not always proprietary. They're not always purchased from a manufacturer. But most of all of the ones that I'm going to show you today are that way. They're always prefabricated. So these are things that, unlike a detention pond or unlike a bioretention cell, we're not constructing them on site. We're installing them on site as a complete full device. They tend to have very small footprints to no footprint when you compare them with other post-construction controls, like a extended detention pond or a bioretention cell. And these devices are all inclusive typically, and I'm going to show you on the next slide what that means. All inclusive, I've defined as all the components that are necessary for stormwater quality treatment and safe operation of the device are included. So some of them also do flood control, not many of them, but some of them do. But when I mean all inclusive, I mean they have everything for stormwater quality treatment and for safe operation. So they're not going to flood out a space. The safe operation means they can handle the drainage that they're going to encounter, and they're going to send drainage that they can't deal with off safely. Okay. So when we think about this, excuse my dog if you hear her barking. I work from my house and someone must have come to the door. But when you think about an extended detention pond, that's not an MTD, obviously, but that is an all-inclusive practice. So all-inclusive means it has inlets to safely, quickly, efficiently deliver water, stormwater, into the device. So this detention pond I'm showing here has two inlets. There's one in this parking lot, and then just kind of a general inlet for this space here. They all have pre-treatment devices, or most of them do. And for stormwater quality, pre-treatment is necessary for most post-construction structural practices. And so for an extended detention pond, pre-treatment is usually something like a sediment forebay or a very large stilling basin or rock apron. Okay, so we've got two inlets here, inlet here and here. So for each inlet, we have pre-treatment. Pre-treatment is taking out heavy sediments, taking out floatables and things like that that you don't want in the main treatment area, which for a detention pond is the main basin. And then for safe operation, obviously we need an outlet structure that discharges the water that's come into the basin in a designed and understandable flow. And we also have an overflow. In this case, it would be an emergency spillway over here to the right, where if this basin fills up and we have a deluge, it's not going to spill over everywhere and kind of flood out the property. The spillage is going to go through a designed emergency spillway and it can head out of the basin safely. So that is an all-inclusive practice. It's got inlets, pretreatment, main treatment, outlets, and overflow. Okay. Same thing for a bioretention cell. This is not a manufactured treatment device, but we've got an inlet through the pavement that directs water into a pretreatment area. Pretreatment for a bioretention cell is usually like a rock apron. Sometimes it's a forebay. Sometimes it's a filter strip. After it goes through treatment, it enters the main treatment area. That's the engineered soil. There's an outlet, which in this case is the underdrain, and there's an overflow. So if this bioretention cell fills up too much and it fills up to the level of this overflow, water's going to bypass the engineered media and just spill over into the overflow and out through the outlet structure. So you're not flooding out the area around it. Okay. Manufactured treatment devices are very much the same. They just look a lot different. They have the same components. So here's a kind of a standard hydrodynamic separator. This one, I usually will put the name of what I'm showing on screen. I'm not promoting any particular brand or manufacturer or device here. But I'm stealing these graphics from their websites or from things that they've given me. So I want to go ahead and put on screen, you know, who gave me that picture or what you're looking at here. But this is an MTD, a hydrodynamic separator. It's got an inlet. The water flows in. This leads from a grate or an inlet drain, probably in a parking lot somewhere. So water comes down. There is an inlet. It flows into a pretreatment area. And in this case, the pretreatment areas, they typically are taking out large floatables. You can see the debris in here. There's a chip bag and a Coke can and things like that. So there's an area where that kind of stuff can be captured and kept in an area where it's easily removed, while the sediment and things that it's supposed to treat are being captured in the main treatment area down below here. I have the numbers switched here, but there's an outlet. So treated water will come back up into this area and flow out the outlet. And there's also an overflow. So if there's so much flow coming into here and this thing fills up, water's just going to spill over into the overflow and head out the outlet rather than have to go through the necessity of going through a main treatment area. So we're going to come back to these components for every type, almost every type of MTD that I'm going to show you. But just know that they have all of the components, or they should have all the components that are needed to ensure they're A, treating water quality properly, and B, being operated or will operate in a safe manner. Okay. Any questions at this point? All right. So let's move on to the types of manufactured treatment devices. And I have a friend down at the bottom of the screen. You can see this name, Jacob Dorman. He works for a manufactured treatment device manufacturer. I think Contact does other things like package bridges and culverts and things like that. But I've known Jacob for a long time. He knows a lot about these things, and we worked together on this particular permit here in Tennessee, where the permit has parsed out post-construction SCMs and BMPs into different categories. And that parsing out, Jacob discovered, fit very well with manufactured treatment devices. And I think this shows that manufacturers of MTDs have kept up very well with stormwater quality technology. They've really been very good about adapting to the fact that we've moved beyond, and EPA has moved beyond just a purely pollutant removal requirement into things like LID and green infrastructure and things like that. So he's the one that kind of came up with the names of these categories. I've adapted them a little bit for my needs, but the first category is a separation category. You're all probably very familiar with hydrodynamic separation. The second is pure filtration. So we're just removing particles through a membrane or media filtration. The third is biofiltration, and we're getting into green infrastructure and LID at this point. And the fourth is hydrologic category, where we're actually doing infiltration, evapotranspiration, and rainwater harvesting. So I'm going to go through all four of these. And Jacob has provided, where he's provided some of the content. I've got his name down here because he's been super helpful. But the first is separation MTDs. And again, this, it starts with, there's a lot of different types of separation, but there can be swirl concentration or some sort of baffling or something that, that kind of brings the pollutants apart. Gravity will allow things to settle out and then cleaner water flows out. So in this case, this is a hydrodynamic separator, a swirl concentrator. You've got water coming in, it's being swirled around. What the swirling does, if you can see by the circles here, it creates a long flow path to increase the efficiency of the unit. So the longer you have the water in there, and the more flow path you're sending them on, the better you can separate out the pollutants. So pollutants separate by gravity. There's a pretreatment device in there that I'll show you in a minute that takes out the floatables. But then you have gravity separation where there's a low velocity flow field and the solids, usually sediment, kind of gradually settles to the bottom. This is a whole lot more instant, and that's why I have instant in quotes. It's not instant as in terms of a finger snap, but it's a whole lot faster than a bioretention cell or an extended detention pond or the non-manufactured controls that usually take at least a day, if not 2 to 3 days, to separate out pollutants from stormwater. So, hydrodynamic processes are much faster. You've got, in the matter of a few minutes or of tens of minutes, you've got cleaner water coming out the other side. Flow controls within the unit kind of minimize the turbulence, make sure the velocity is correct for whatever mechanism is being used, prevent flow surges and resuspension of sediment that's gone down to the bottom here. It retains the floatables. And different units work in different ways, different hydrodynamic units. But this one in particular is a swirl unit. And you can see water coming in, floatables shown by red and yellow get taken out, and you've got cleaner water swirling around in here. Eventually some settle out to the bottom and out the discharge. So the advantage of separation MTDs are they're efficient. You get efficient pollutant removal fairly quickly. They're quite durable when they're maintained. We've seen them be used for years and years and years. A lot of times we see them used for pre-treatment because they're really good for floatables removal. I have seen these things put upstream of, say, an extended detention pond or a detention pond. And so you're getting, at least for that first flush of the storm, you're getting floatables removed. They don't even get into the sediment forebay. There's a number of different applications for these. They're good, but not great for sediment removal, sediment being measured by total suspended solids or TSS. So they're not the highest pollutant removal you're going to get, but when you're low on space and you need something to remove sediment and pollutants attached to sediment, MTDs are a good option. The disadvantages obviously are they're not going to remove dissolved and soluble pollutants. And in Oklahoma, in the OKR4 permit, you're leaning into pollutants beyond TSS in ways that many other states aren't yet. It's coming for everybody, but you do have requests and requirements in your permit for TMDLs and impaired waters that go beyond sediment removal. There's metals, there's nitrogen, phosphorus, and other things. You don't see a lot of that in other permits yet, but the MTDs, they're already there in that some of them can do that sort of thing. Separation and MTD, not necessarily, but we'll get to some of the others that do. MTDs in general have a very high maintenance need because they They deal with a lot of water very often, and they're very good at taking out the floatables. So they require frequent cleaning. I put this as a disadvantage because we don't see cleaning get done a lot yet. We're still in a world across the United States where maintenance of post-construction practices is not done very well, even in states that have stressed post-construction for quite a while now. They're out of sight, out of mind, because they're usually under a manhole or something like that. If a property owner doesn't know about them, they're not going to go looking for them. And again, that leads back to the difficulties in maintenance of post-construction BMPs. Often the owners don't know what's on their property. But at least you can see a detention pond, at least you can see a bioretention area. MTDs, often you can't even see them, so you don't even know they're there. The owner doesn't know they're there. A lot of times, because they're only good but not great for TSS removal, they have to be put in a treatment train if there is a requirement for 80% TSS removal. A lot of states have a standard for 80% TSS removal. That's their post-construction standard. These can't necessarily be used alone to meet that. They won't necessarily get up to that level of treatment. So they're great in a treatment train though, and I've seen a lot of application where that's concerned. So an 80% TSS standard you don't have in the OKR 404 permit. The city of Norman has an 80% TSS removal standard if post-construction devices are placed in. I don't know if that is across the board for Norman, but I am beginning to see a little bit of that in Oklahoma. So it's not rare, it's very, very common to have that. More on hydrodynamic separation, the typical components, as I showed before, you've got the inlet, the pre-treatment, main treatment, an outlet, and an overflow bypass. This is what that looks like in the field. Again, this is a rendering or a drawing from Hydro International. The water's going to come off this parking lot, go into this inlet, be delivered to the MTD through the inlet, get swirled around, and cleaner water will go out. Okay. More examples. A lot of different companies have their own swirl chambers and things like that. There's Context swirl chamber. It operates just like same mechanism, everything. It just, the inside looks a little bit different. There you see it's got a inlet on top, inlets coming from other places. The sediment drops down to the bottom. This is what it looks like kind of before it's installed. It's what a real one looks like down inside. Here's a different type of hydrodynamic MTD. This one is a baffle chamber, but it's also got a nutrient screen. So water would come in. Say this water is filled, we've got a nutrient issue where this is located. The water would come in with leaves and other mulch and other things that would potentially cause nutrient issues. Those are captured in this screened box, which is easily accessible through the manhole covers here. So all the leaves and things are captured in here. Sediment laden water is then baffled through these baffles into the outlet. So what that might look like, again, through a rendering. This is a little bit different unit. Water is delivered in, leaves and things are captured here. Sediment is captured down here. Cleaner water goes out. There is a bypass in that if this is a screen right here, so if a lot of water is coming in, this thing is overwhelmed, it's just going to pass right through the screen and on out. It doesn't go through all the baffling. The major downside of hydrodynamic separation is maintenance. There are a lot of, I've seen a lot of pictures like this. I feel like this one is a little bit staged because these things look new. There's some Goya beans and a Modelo here, so we've got a little ethnic flavor to this one. But you could go out, if you Google these things, you could go out and see this stuff can just get caked and caked and caked in these things until they're full and you can't recognize what is in there. You don't see bottles and things necessarily. You just see this caked goo, dried up substance in there that is very, very hard to remove. So if they're not maintained frequently, they can get bogged down very quickly to the point that they do become drainage issues because they get filled up so much that even their overflow is stopped. So maintenance is needed. Every post-construction BMP needs to be maintained. The difference in MTDs is they're small, they fill up very fast, they're efficient at what they do, so they need much more frequent maintenance. Any questions yet on hydrodynamic separation before I move to another type?
Not yet.
Okay. So the second is filtration. And again, my friend Jacob gave me some pictures for this that make it easier to understand. The main process is physical removal of particles. Either you're putting them through a screen or a membrane and the particles are getting stopped from getting through. The cleaner water comes out the other side. Or you've got some type of media that they go through, a depth or a bed or something, like a Brita filter. You put water in the top, it goes through activated carbon or what have you, and you get clean water down in the bottom. So filtration works in one or both of these ways. You may be familiar with these. They've been out for quite a while. This is a filtration MTD called a jellyfish, and different companies have their own version of the jellyfish. This is a filter cartridge, and there's numerous of those depending upon the sizing that you need. So there's inert media and the actual filter screening here, or the fabric that's placed over there, that provide barriers to pollutants getting through. Okay. So the advantages of this are that they're very good control of solids and attached pollutants. So you're getting whatever attaches again to sediments and solids like metals and phosphorus, you'll get good control. Again, not great, but good. One of the reasons for not great is maintenance again. They typically have a very high maintenance need. You've got to replace the filters. You've got to buy them and replace them. You got to replace the media if the filter isn't messed up. And so their longevity is a concern. I've had clients that have concern about, well, what if Stormwater 360 goes out of business and someone has a jellyfish and they can no longer get the cartridges? Personally, I don't know if one company's cartridge fits another company's device. But I've heard that be a concern because you've got to, purchase new and replace these from time to time. These also typically need to be in a treatment train. Again, they're good, but not great. And one of the problems with these is because you've got media and paper here, there is the potential for leaching of other substances into the water that you're sending out. I don't know much more than that. That came from Jacob, but that was something new to me as I created this presentation, that some folks have discovered, I guess, some leaching of different substances. So these are filtration MTDs. There's also assorptive media filtration, and this is a little bit more targeting to things other than TSS. They address TSS as well because that's going to come through, sediment's going to come through. But because you can vary the media that's in the cartridge, and this little picture down on the lower right kind of shows what the media can look like, that media can act as an absorbent or a sorb for dissolved phosphorus and other sorts of dissolved and soluble pollutants. So you got an additional level of treatment here for things. There's different media options: activated carbon, zeolite, compost, biochar, different resins and things that work chemically to remove soluble pollutants from the inflow. So this particular device, you bring water in, it soaks in through, there's still that paper membrane. The media is within the paper, you can see here. It soaks into that, And then this has a check valve. So the filtered water goes out through this center outlet here. But as the water rises and it gets so high, there's a check valve in here that just allows water to kind of bypass and go through and get out more quickly. So these have an overflow as well. I'm not quite sure kind of where that overflow starts functioning, but there is an overflow, so you can get water out more quickly. This is what that looks like in the field. Again, they look very similar to what we just saw, but these are now filled with sorptive media. And you can choose the sorptive media. So they're very flexible. You can select the media based on the pollutant you have. And Jacob says this prevents leaching. So you don't, you can take away that issue of having the water come out with something in it that you didn't intend. So it's going to remove those soluble and dissolved pollutants. Again, this might need to be in a treatment train. It really depends on what pollutant you're targeting. If it's TSS, then yes, you're probably going to need a treatment train. If it's something other than that, like phosphorus, it really depends on, what the treatment level is that this can provide. And I'll show you in a little bit kind of how you can go find that, how you can figure that out. There is the high maintenance need, and as I said, the device longevity is a little suspect simply because they've got to be maintained. If they're not, they can get damaged. And the fact that companies do come and go. Now, Contact, Stormwater 360, a lot of the companies I'm going to show you have been around for a very long time. But I don't know that buying these from a company that's brand new and they don't have a lot of play in the industry yet, I don't know if that's really a great thing to do. So they have all those same components. This is a little bit different where you've got an inlet coming in. The pre-treatment here is a screen. I'll show you what that looks like in a minute, but the water comes in, it goes through this screen. The floatables are captured here, and then it soaks up into the filter unit here. And then cleaner water goes out the outlet. This has a little bit different configuration for an overflow bypass. So you can see there's a lot of different ways that these are all put together and they work. This is the same type of Hydro International upflow filter, but in that same rendering and in a larger situation. So we've got that water coming off the parking lot. It goes into the inlet and drops through these screens. These are the pre-treatment screens here. And then as that fills up, the thing fills up, we begin to have water go through the filtration units here, and cleaner water will come out through the discharge pipes here and here. There's that overflow bypass. So if this is full and water's overwhelmed, it's just going to bypass the filter unit, the pre-treatment, and just come right out. Okay. More examples of filtration MTDs. I like this picture. We've seen this already. I had that in a picture already, but this kind of shows how that pre-treatment works. Dirty water's coming in. It's going into a pre-treatment chamber where only pre-treated water is then allowed into the cartridge unit area. Notice how high the walls are here. This is not a lid. If you look at it down here, this is just an interior wall. So this pre-treatment unit's going to fill up, drain into this area where it hits the filtration media, which then drains out into this outlet area. So here's the outlet area here and cleaner water going out. Clearly, if this fills up, it's not going to drain into the cartridges. It's just going to go right through. Okay, go through pre-treatment and on out. Okay, and that's what this looks like. So again, in stormwater quality, remember, we're always treating a very low volume of water. So we don't need, the 25-year storm to be treated. We're treating something less than the 1-year storm usually. So this low wall will provide pre-treatment for that 1-year storm and let everything else pass through if it gets too high. A little bit different example. This is a downspout filter system. It does have pretreatment. I was kind of surprised to see the pretreatment screens on here, but it's the same kind of concept where there's sorptive media in here, and this is treating metals. So it's getting water off of a rooftop. Rooftops don't often have a lot of pretreatment need. You can, I guess, leaves and things that come in. But it goes into the sorptive media and you get cleaner water coming out. So these are new. I hadn't been exposed to these until about 2 years ago. And where you have metals impairments, they create these things simply for downspouts. Okay. Any questions on filtration MTDs before I move on?
Yes, Mary, we do have a couple of questions. So Jordan asks, with the sorptive media, did you say that leaching is prevented because you can select a specific media that targets a pollutant?
Yes, that's my understanding, is that because you are selecting a media that's looking for a particular pollutant treatment, that you have less propensity for leaching.
Okay. And then I actually asked with the sorptive media filtration devices, what is the flow rate through the filter system? And then what percentage, or do you even have an estimate of what percentage of the stormwater would actually be treated during some of those larger or more intense rain events?
Yes, and if you can hold on, I will show you that as we get toward
Oh,
more slides into this.
perfect.
Okay.
Thank you.
Right. So the third type is biofiltration MTDs, and biofiltration comes from biologically active filtration. We're beginning to get into green infrastructure here because we're depending on plant uptake, an engineered media sorption, and anoxic denitrification. So we want infiltration into a media and into an internal water storage area to allow pollutant removal to take place. And this comes out of, LID really has been known in the agricultural world for some time now. As water soaks through a soil and you've placed soil properly, you get this assimilation by plant uptake. You get absorption, infiltration, mineralization, nitrification through soil, topsoil and things. But then as you send it further down and get it cycling through different media, you get absorption, infiltration, denitrification, and anoxic, microbial uptake. So you're depending on plants, soil, media, and also microorganisms to do a lot of the work here. So you've got treated water coming out the end. So when you think about a bioretention area, again, this is not a manufactured treatment device, you're doing a lot of the same things where you're depending on evapotranspiration and infiltration into an engineered media, an internal water storage layer, and then through an underdrain to get the work done of pollutant removal. Okay. So biologically active means we've got plants, we've got sorption, we've got microbial action, and anoxic denitrification. Okay, so this is what an MTD, what we were looking at was a bioretention cell. This is basically a bioretention cell in a package. Okay, I love these things a whole lot. I think they're going to have a lot of play in the world. If you look at different design manuals, you often see a design specification for an urban bioretention cell. And urban means it's defined by being surrounded by concrete. So it's a bioretention cell that's going to take water purely off of concrete and then send it through the bioretention media and then out into an underdrain. A lot of times in the past, people had to construct those themselves. MTD manufacturers got on the train and said, well, we can do that and just bring you the full package. And so I think these are going to be very, very popular because they have a low footprint. Everything's under the ground and they can really provide a nice landscape as well. The advantages of biofiltration MTDs are they have great pollutant removal. You will get 80% and up with these, even though you do get some runoff volume loss through infiltration beyond the unit itself if there's an open bottom. and also evapotranspiration and plant uptake. But the dominant thing here is really the infiltration through the media and then out through the underdrain. So you do have an underdrain here. Let me go back just a little bit. I wanted to tell you about this upturned elbow. We only get anoxic conditions if we get some circulation in here. And so if there was an underdrain at the bottom, everything, because the infiltration rate here is so quick, everything would just go right through. You would get infiltration and filtration, and cleaner water would be sent out the bottom. There are plenty of bioretention areas that are designed that way. But when you design the underdrain with an upturned elbow, the water will stay in this area between the invert of the underdrain and the invert of the top upturned elbow. The water will stay in here until the bioretention area begins to fill up beyond this invert. And so by Bernoulli's rule, by Bernoulli's equation, you're going to get that water. You'll finally have the pressure to send drainage out. So having this internal water storage area between this invert and this invert really helps with the anoxic treatment in this area. So that's where you're getting a lot of the denitrification, and you can address nitrogen as a pollutant. Okay. I don't have a lot of pictures of MTDs that show that, but that's an important feature of these types of MTDs. Okay. So they get great pollutant removal. You don't necessarily have to use these in a treatment train, but you can. They do, they're very flexible. You also have lead potential. So if you have a developer that's really trying to do things in a green way, these can get them lead points. They're very flexible, like all. You can have a lot of different sizes, but they also provide you with aesthetics. And the maintenance, routine maintenance, not remedial, but routine maintenance is fairly easy. You're picking up trash, refreshing the mulch, and basic plant care. The disadvantage is you really have to be careful about what you select, and the manufacturer will help you do that for plants because you want to avoid the root damage. And I think for trees, that tree is going to grow and eventually going to need to be removed and replaced. So there's a lot of these that you don't necessarily have to use trees here, but they are an option for street trees as well as stormwater treatment in the right of way. And they're really best suited for a clean environment. So you don't want to get that engineered media below the mulch to get clogged up, because then you have a more remedial maintenance that you have to do. So you want to put these in places in parking lots for office spaces or medical buildings, or just in places where you're going to have generally a clean environment from a post-construction standpoint. So they can be quite large. So this is a tree planter that's going in. I don't know where this is, but they can be quite large. You can see, there's a ladder inside of here. And so if you had to do remedial maintenance on this, that could be quite daunting. You'd have to pop the top off and refill it with all that soil. This is what, we're getting smaller here. The water's going to come in through this inflow. This is some sort of media that's placed in here, the engineered media, and the plants will go through the top here. But you can see if you had to replace this media a lot, that would be kind of problematic. Getting smaller, here's adding a media. And this particular manufacturer showed that the media needs to spill over so that the plant roots will not damage this. The plant roots will have a chance of getting out, and you have a longer lifespan with the plants that are put into this. And then this is typical routine maintenance. Forgive me for the fuzziness of these pictures, but it's the best I could do. And the numbering here, I took out the pictures that showed an inspector with a clipboard and things like that. But you're basically popping the top off here, the grate. You're taking out the mulch and erosion control stones that are in this thing. Replacing the mulch, taking out the trash up here, replacing the mulch, and then cleaning up around, putting the grates back on. So they're not very difficult to just do routine maintenance on. You got to do plant care as well, make sure the plant's watered. They have all the components. There's an inlet. Pre-treatment is provided by the bed surface. Some of these have pre-treatment rock aprons and things like that, so that you don't get a lot of mulch movement, things like that. It soaks down into the engineered media, down into an outlet with the stone jacket and the perforated underdrain, and cleaner water heads out. There's also a large flow bypass. This one, the bypass is in the bed, where as this fills up, when it gets to the point of the top of this pipe here, the water's going to bypass the entire system and flow out. Okay. That has different ways of showing. I'll show you different ways of bypassing, but this is a different type of mechanism. Same biofiltration MTD, different plants in here. Water comes in through the plants, also through an inlet. So think of this on the edge of the road. A curb inlet's going to let water in. Pre-treatment is provided by the plant bed. Pre-treatment is provided by this screen box here that would be easily accessed through the manhole on the top. And then water fills up this basin and goes into here and then soaks into the engineered media and on out through the underdrain. There is a bypass here as water fills this chamber. When it hits this level, it's going to bypass, and there must be another pipe under here somewhere that allows water to bypass this entire thing and head on out. Different versions of that. This is the one I showed previously. The bypass, I think, is in here through this pipe. This is an old castle biopod. This is the same kind of concept, but from Contec, it's their Filterra. And the bypass is simply done at the inlet. So there's stormwater flow. You've sized this inlet to a certain size and velocity, and everything over that goes to a high flow bypass inlet. So a little bit different way of doing things. They're very flexible. I show you this really to show you the different sizing. This one also shows the upturned elbow under drain, things like that. And so there's just a lot of different ways that this can be done. I think they're going to get very popular is my thought, because they just seem so easy. Okay. I'm going to speed up just a little bit to make sure we don't go over time. Hydrologic MTDs are the same thing, but without an underdrain. They don't necessarily have plants either. We're really just relying on infiltration and maybe evapotranspiration to do the work. They have the highest pollutant removal because you're not sending any water off site. With that water quality storm event, again, the smallest volume of water you're trying to treat, everything goes down and infiltrates in. The disadvantage is that the feasibility of this is really limited. You've got to have the right soil, you've got to have the right environment. You don't want to have foundation problems or upswelling problems. And so I don't see these used very often simply because infiltration feasibility is we have to be very careful about that. The other type of MTD is a cistern rainwater harvesting. Again, you're removing water from the system. That's why it's a hydrologic MTD. You're removing water. And these, as an MS4, you really just have to be careful because you've ensured that these are post-construction MTDs. A cistern really has to have a frequent, year-round, and provable use for that harvest water to be used for post-construction compliance. To just say, well, I'm going to water my plants. Are they? They probably are, but, is that a frequent year-round use? No, that's not. So we're looking for things like it's tied to your toilet flushing system. You use it for something that you have a frequent need for. And then I worry about what happens when property ownership changes when it comes to cisterns. I might think it's a great idea to have a cistern in my office building to flush the toilets and use for toilet water. Well, a new property owner comes in and says, I don't want to deal with that. They just want a traditional plumbing system. So as a MS4, you have to think about those things because you have the burden of oversight of these things. You size these things based on a peak flow. Most other post-construction BMPs are sized by volume, but MTDs are sized by a flow rate. And you want to get the maximum flow rate that these things are going to encounter for the design storm. Again, small storm events. So we're talking about the 1 year storm or less. Okay. But you want that max intensity because you want that max peak flow. So it's very much like a rational method equation here. You want it to capture only pavement. And so to find that max intensity to put in this equation, let's say our site is in Oklahoma City and it has a time of concentration of 15 minutes. We would go to NOAA Atlas 14. Let's say it's the 1 year storm is our design event. 15-minute time of concentration, our max intensity would be 0.747 inches per hour. Okay, we're not really sliding up into a recurrence interval that's larger than a 1 year event. That's just not what we do for water quality. I'd say the highest would be 2, but we're not trying to handle the 5, 10, 25 year event with these things. So they're not huge unless you have a huge site. As far as pollutant removal percentages and how much TSS or how much phosphorus does it remove, we use an industry-wide standard. Back in the day, when these things first came out, it was problematic because manufacturers would say it works because we say it works, and they had their own data to kind of show that. But as an MS4 who has the burden of compliance with a state or a federal regulation, you need to be able to show that, yes, we know that it works. If it's built in this way, we know that it works. And you can't necessarily rely on the manufacturer to say that. So it's almost like we were kind of in a snake oil salesman situation back then. And there's a lot of great manufacturers out there. But it came down to MS4s had a liability. They needed to know. There wasn't any independent testing. Testing and verification require a lot of resources. And there were a lot of kind of technical things that, got bound up in everyone's mind on how to do this that kind of slowed progress. So over time, what we decided we needed was industry-wide standards. There's not a national program yet, but there are 2 programs in the US that are used by many, many states to be able to say we can rely on this device and it provides a certain level of treatment. Those are from New Jersey and Washington. If I have time, I'll talk about Georgia, but I'm not going to do that. I probably won't have time. So New Jersey Stormwater, NJDEP, New Jersey Department of Environmental Protection, so their regulatory agency in their state has a certification. Their certification addresses all types of MTDs. We don't need to address the hydrologic ones because they're not discharging water. We just need to address the types, separation, filtration, and biofiltration that send water out the other end. Okay, the definition in NJDEP's protocol generally follows what shows up in permits across the nation. Okay, they use the New Jersey Corporation for Advanced Technology, or NJCAT, to do the independent lab testing and verification. It's only in a laboratory, so we've taken geography out of the equation. NJDEP does a lot of testing to certify a TSS removal rate. So it's only TSS, and they're only going to give an 80% TSS removal or a 50%. So if they get an 80%, generally you can use that as a standalone MTD. If it's 50%, you need it in a treatment train, more than likely. Okay. It also specifies a maximum treatment flow rate that pollutant removal is good for. So you've got some context around that pollutant removal number. So if you go to NJDEP's website, you just look up NJDEP MTD certification, brings up this website. This is what it looks like. you scroll down here, and here are all the green infrastructure MTDs. This would be your biofiltration MTDs. And then they have a ton of hydrologic separation and filtration MTDs. So this goes on and on. There's just a ton of them. But you would click on the certification, and a letter comes up from the state of New Jersey DEP that shows the TSS removal rate as certified by NJCAT or as determined by NJCAT, the maximum treatment rate, flow rate for that TSS removal, as well as sizing information. Another nice thing about NJDEP is you can click on these, and they also have the inspection and maintenance manual that comes from the manufacturer, which is golden. That's fantastic. Ask for those with every plan that you get that has MTDs in them. So it's a really nice setup that they've got. The advantages are you've got this good solid testing protocol. You've got a flow rate calculation that's shown in detail, and you've got parameters around that TSS removal rate that they give. Their website is super easy to use. You know, I did it, and I'm not that great on websites, so it's no problem. Disadvantages are it only addresses TSS, so we've got a limited pollutant there. The flow rate doesn't translate outside of New Jersey, so it's a guide only. You've got to write policies around how to use that. And then there's a lot of code references and things that are pertinent to New Jersey, but not really relevant in Oklahoma, that you just kind of have to get around. Washington TAPE, this is the state of Washington, has a TAPE program, technology assessment protocol. It is just as good. It goes beyond TSS removal and goes into phosphorus, oil, copper, zinc, metals, things like that. It also does field testing, not that that's important from Washington to Oklahoma. It has different uses. So there's a general use which means it achieves treatment goals. A conditional use, it means more testing. A pilot use is where the vendor or the manufacturer and the developer are agreeing that, you know, we don't know about this one yet, but you know, it passes on certain things. Again, they've got a website. It's a little bit more involved to deal with, but you're clicking on the device you want to look at. You get that letter that comes up. Okay, so this had the advantage of more than, you know, addressing more than TSS, but it still has some of those disadvantages in that it's Washington and things don't necessarily translate over. What most states are doing are translating over the TSS and the max treatment rate that goes with that TSS removal or goes with that other pollutant removal, the treatment rate, flow rate, and the pollutant removal, and then writing policies around how to use those things. But you've got the backup of having testing protocols, so you can go to your state regulator and say, we know that the MTDs that are put into our MS4 work. I'm not going to go through Georgia. It's not really got anything better than New Jersey and TAPE. There are other tools out there that for various reasons I don't recommend. Either they're very limited or they're not actually testing anything. They're just giving information. So it's New Jersey and Washington right now are the good ones. There is a National Municipal Stormwater Alliance is trying to come up with a national testing and verification program that I think would be very interesting for Oklahoma. And it relies on a lot of different partners to buy in. So that's being worked on. There's donations they're taking. I think it has a lot of groundswell of opportunity. So keep an eye out for that. So crafting local policies. I'm coming down to an hour here, and this is my last slide. Allow only those manufactured treatment devices that are backed by reputable independent results. Don't go back to the snake oil salesman scenario. There's a lot of fantastic manufacturers out there that have very good products. there are new products that will come online. I saw one at the LID conference in Oklahoma City just last year that looked very promising. It's a big step for these guys to get a product out there and go through NJDEP and Washington Tape to get them certified. If they've gone to the level that they need to do that, then I would say they're probably a pretty reputable company, and that, you know, you can stand behind, and they can stand behind what they're putting out there. And, you know, you just got to specify the test standards or the testing protocol that you allow in your design specifications. I wouldn't put that in the ordinance because these things, I think, over time will change. And you want to take advantage of anything new that's coming out that may be better than NJDEP or Washington. Don't allow MTDs where they won't be maintained. So an MTD that is proposed to be put in a common area for a homeowners association, and that homeowners association doesn't really have any space that you know they're going to take care of, like a pool house, a pavilion, tennis courts, things that, you know, they're generally going to maintain. I wouldn't allow an MTD in there because you have to have that frequent routine maintenance. A lot of my clients don't want MTDs in residential areas, period, because of the issues with maintenance of post-construction BMPs on residential properties. But you just need to think ahead when they're proposed of, is this really going to be maintained in this situation? Okay. Give yourself as an MS4 the ability to deny those kinds of proposals. Develop good relationships with MTD manufacturers and vendors. They are fantastic. Now, they do have a sales piece to what they do, but they're very knowledgeable. They're very hands-on. A lot of times they help with selection, design, and construction. They're great at education. They can tell you far more about these things than I can. You know, they're generally very willing to come in and give seminars like this, but much more in depth into what their products do. They're great at educating all different levels of stakeholders. And I've seen them work very well as liaisons between a local government plan reviewer and a developer and a site design. They really can be very good. And then I would suggest that you pilot these things by using them on your own properties. Municipal local governments tend to have the equipment on hand to maintain these things. They also have the people that are getting paid to maintain these things. The way to get to know them the best is just to put them on your own property and begin using them, begin seeing how frequent do they actually need to be maintained in your situation, in your topography, in your geography, so that when you see these on private properties and you've got to oversee their maintenance, you kind of know what you're doing. So I am 2 minutes over. I didn't leave much time for questions, but I have time to sit here and answer questions if folks want to ask them. I apologize for the length of time I went over.
Oh, that's fine. I think we did lose a couple people, but sometimes people have other meetings that they need to get to anyway. But Mary, that was a wonderful presentation. Gosh, I learned so much. I thank you so much for your time. We don't have any questions at this time, but of course, as she mentioned, if we can hang out here for a few minutes and receive those questions. If you'd like to unmute yourself at this time or type it into chat, you're welcome to do that. I did want to mention really quick, I posted into chat a reminder that this video will be available on our COSWA YouTube channel. So we'll have a recording of that available if anyone missed it or if you want to share it with a coworker. And of course, if you wanted to request a certificate of attendance for today's webinar, just send me an email. With that, I'm going to go ahead and stop the recording and we'll just hang out here for a little bit and receive your questions if you have any.